Welcome back. This is the second Desmos video for U9D6 IM2. So we have this big rectangle and we have to take away these two little yellow rectangles. Well, let's talk about the big rectangle. That's the purple rectangle. What is the area of that big rectangle? Area is going to be base times height because it's a rectangle, and base is 24 times 20, which is going to be 480 centimeters squared. Now let's talk about that little rectangle. We have two little rectangles. Now, do we know any dimensions? We know that this length is 20 and this length is 9, so this has to be 12. Okay, do we know the width of this rectangle or this width? We don't know that, but we do know the combined width because we know that the total width is 24 here and minus 6 minus 6 minus 2. So this, whatever this length plus this length, has to be 24 minus 12, 14 is 10. So these two have to add to 10. That combined is 10. So do we really care whether we can actually even just bring those two rectangles together right next to each other? Doesn't really matter because we're dealing with area. So the area of the orange area is going to be 12 times 10. That's going to be 120 centimeters squared. So the area of the shaded area now, the shaded area really is the purple rectangle minus the yellow area. So this area is going to be 480 minus 120, which is 360 centimeters squared. That's my area. Next up is the blue shaded area. Okay, so how do I figure it out? Do I know how to calculate the area of the blue circle? Because the shaded area is going to be the area of the blue circle, take away the area of the rectangle. To figure out the area of the blue circle, the big circle, we need either radius or diameter. Do we know radius or diameter? Yes, we do, because we can figure out this length. Okay, we can figure out this length. How do we figure out this length? We're told that this base of this rectangle is 9. The height of the rectangle is 12. So what do we know about this length? Well, for that, if I call this x, I can use Pythagorean Theorem. So I can say that length x squared is going to be the leg squared, that's 12 squared, plus 9 squared, which is 12 squared is 144, plus 9 squared is 81, that's 225. And so x squared is 225, so take a square root of 225, and that should give me x is equal to 15. So I know that x here is equal to 15. That means the diameter is 15. So what do you know about radius? Okay, the radius is going to be half of the diameter, so the radius is going to be 7.5 units. Okay, so now can we figure out the area of the blue circle? Okay, so area of the circle is going to be pi times r is 7.5 whole squared. Okay, and when I use the calculator, it gives me 176.625. Now let's calculate the area of the rectangle. area of the rectangle is going to be 12 times 9, which is going to be 108 centimeters square, or units square. So now the area, the shaded area, is really the circle area take away the rectangle inside. So what is the area now? The area is going to be 176.625 minus 108, and when I use the calculator I get 68.625. So I type that in. Great. Let's move on to the next card. This is a challenge card, optional for extra credit. Alright, so a cookie baker has an automatic mixer that turns out a sheet of dough in the shape of square 12 inches wide. His cookie cutter cuts 3-inch diameter circular cookies. The supervisor complains that too much dough is being wasted and orders the baker to find out what size cookie would have the least amount of waste. Determine how much cookie dough is wasted when 3-inch cookies are cut, then try a few other cookie sizes. Briefly describe your findings. Well, here we go. Alright, so if you have 12-inch, to simplify this, let's make this 12 by 12. Let's make this 12 by 12 inch square. Oops. Okay, so if it was 12 by 12 inch square, if I have 7-inch 3-inch diameter circular cookie cutter, that means this is going to be 3 inches, 3 inches, 3 inches, 3 inches. So you are going to be able to fit 4 by 4, so 16 cookies. So this is going to be 3-inch cookies. And that's going to create how many cookies? That's going to be 16 cookies. Okay, and what is the radius of the cookie? Each cookie is going to be 1.5 inches. Okay, so now let's calculate the total area. The total rectangle area is going to be, the total area of the rectangle is going to, or square, is going to be 12 times 12 inches, which is going to be 144 inches. Okay, now then from here we can calculate the area of the circles. Okay, area of one circle is going to be I'm going to say 16 cookies. 16 cookies, and that's going to be, one cookie is going to be pi times 1.5 squared, and then we are going to that we're going to multiply 16 to it because there are 16 of them. And if I use the calculator and leave it in terms of, that's 1.5, okay, in terms of pi, I get 1.5 squared times 16 gives me 36. So it's going to be 36 pi inches squared of cookies are being made, and what is remaining is 4 inches squared minus 36 pi inches squared. So that's going to be the case when you are dealing with 3-inch cookies. Now let's consider what happens if we increase that to 4 inches cookie. So first of all, you should be picturing this. Okay, so in this case, you should be able to fit in 3 cookies side by side, right? and considering that we are still dealing with 12 by 12 inch squared of cookie dough sheet. Alright, and then what is the diameter in this case? The diameter is 4 inches, so the radius is going to be 2 inches. Okay, so the radius is 2, and there will be how many cookies? 9 cookies. So the area of the square is going to be the same, but what about the cookies? How much area is 9 cookies made up by 4 inches in diameter going to take up? That's going to be 9 times, because there are 9 cookies. How about 1 cookie is going to be pi times r is 2 inches squared. So it's going to be 4 times 9, which is 36 pi. So we're actually creating 9 4-inch cookies is going to use up exactly the same amount of cookie dough as creating 16 3-inch cookies. Alright, so that's the conclusion we have so far. Let's see if we can do, let's do 2-inch cookies. Let's visualize 2-inch cookies. Now if I am doing 2 inches cookie, I can fit in 1, 2, 3, 4, 5, 6 by 6 cookies. 1, 3, 4, 5, 6. So 6 by 6 inches cookie, because each of the cookie diameter is 2, so the radius is going to be 1 inches. And that will create 6 times 6, so it's going to be 36 cookies. So let's talk about what is the area of 36 of these little cookies. That's going to be 36 times, each cookie is going to be pi times r. Radius is 1 squared, and that's going to be 1 squared is 1 times 36 is 36 pi. Notice that we are it does not seem to be matter, and we're still using 36 inches pi area of cookie dough to create different numbers of cookies with different size. So is there going to be any difference in the amount of cookie dough? No, there isn't. So it really does not matter, but you do need to explain this. Next up is finding the area of the blue shaded area. Okay, and if you'd like to get some more hint, focus on the left half only. If you just cover the left hand side, cover the right hand side, you will see that the left hand side and the right hand side are exactly symmetrical. So if you figure out the area of half a circle, you can figure out the area of the whole shape. Okay, so to do that, you need to be breaking this apart to the circles that you can figure out. Okay, so let me draw half a circle right here. And I am told that this is 30 here. So and it looks like it's being divided up into a third. So that's going to be 10 here, and that's going to be 10 here. And what's going on here? We have a half a circle with the diameter of 10, and another half a circle with the diameter of 20, and then third with diameter of 30. Okay, so and the area that we are interested in is this area and this area. Okay, so what we can do is figure out the area of the big circle, area of the medium-sized circle, and finally the area of the smaller circle. Okay, here we go. So the area of the biggest circle, in this case the radius is, diameter is 30, so radius is 15, so the area is going to be 220 pi. The area of the middle circle is, the radius diameter is 20, so the radius is 10, so that's going to be 100. That's a typo, it should be 100 pi. And then area of the smaller circle is going to be pi times 5 squared, so that's 25 pi. Of course, we're dealing with half a circle, so we're going to be multiplying that by half. However, we need to subtract this from this, and then